Good afternoon, geometries period 6 and 7. It's Mays coming at you from room 308. It's Tuesday. It's the 26th of May. You've got 1, 2, 3, and what's left of today academic days left to get your assignments turned in. I can still take a few of them next week, but please try to get all you can in done this week, all right? Because on top of all of that, I posted a Chapter 11 CFC out there for you to do. And to go with that, I'd like to give you a little help with that. There's some some unique stuff out there that I thought was kind of cool. Combine some stuff up from chapters 10 and 11. So let's see what we got here. All right, so chapter 11, section 11.8 has to do with volume and surface area of a sphere, okay? Now a sphere, don't you just love my artistic talent here? A sphere, the geometric definition of a sphere is all points equidistant from a center or from a point. A sphere has an infinite number of diameters. If you can imagine that center point there, I mean, how many sticks could you run through it? An infinite number is the right answer. And every diameter has something called a great circle. So on a sphere, there are actually no parallel lines. You cannot draw parallel lines because we define the line as the great circle. Okay, and no two great circles are parallel. All right, so here are your equations for the volume and the surface area of a sphere. Now, if we were in class, we would actually derive these, but if you really want to know how they got that, you can YouTube it, all right? But for right now, the volume of a sphere is 4/3 pi r cubed, and the surface area is 4 pi r squared, all right? So the example I'm going to give you, the radius is 8. If you plug 8 into the volume is equal to 4/3 pi r cubed, you will get 8 cubed divided by 3 times 4 is 682 2/3 pi cubic units. Notice I left the pi in there. That's an exact solution to this problem. And the surface area, 4 pi r squared, if you put the 8 in there, 4 pi 8 squared, 64, 4, 256 pi squared units. So that would be the surface area and the volume of a sphere of radius 8. Okay? All right, now what can we do with that? Well, here's the problem you're going to face on your CFC. It looks a little bit like this, okay? I give you a circle. I tell you the center is at C. I tell you that CD and CA, that forms a 60-degree angle, okay? So you've got this BD, and I tell you the length of BD. BD is, in this case, it's 12 units. I don't remember what it is on your CFC. But you've got a 30, 60, 90 right triangle. So you need to remember those rules. If the long leg is 12, the short leg is 12 divided by the square root of 3. And 12 divided by the square root of 3, rationalizing the denominator by multiplying the top and the bottom by the square root of 3, and simplifying, the short leg is 4 square roots of 3. And the hypotenuse is twice the short leg. Ta-da! So that means that the hypotenuse of this thing is 8 square roots of 3. Okay? So, if you want to find the volume of this sphere, it'd be 4/3 pi times 8 square roots of 3 cubed. Now remember, the square root of 3 cubed is 3 square roots of 3. It's the square root of 3 times the square root of 3 times the square root of 3. Don't mess that up. And then, of course, 8 cubed, whatever that comes out to be, okay? Now, the surface area is 8 squared, 64, square root of 3 squared, 3. So the surface area would be 4 pi 64 times 3, whatever that comes out to be, okay? So that's how you would do that problem. The whole puzzle here is recognizing that you've got a 30, 60, 90 triangle and remembering those ratios for those legs of and the hypotenuse of a 30, 60, 90 right triangle, okay? All right, now, in the words of Emeril Lagasse, let's kick it up a notch. That's kicked up quite a few notches, doesn't it? All right, so you have to excuse my drawing. It is certainly not to scale. That point A is supposed to be the center of a sphere. Now what I did, I took it's cutting an orange in half. Okay, this is a cross section of a sphere, and I drew all these funky little lines on it for you. Okay, now notice that this appears to be laid out on a Cartesian grid because you've got lots of x and y values. It is. It's laid out on a Cartesian grid. Okay, Now you should be able to tell me a lot of lengths of these pieces. And that means that you've got two lines that are parallel. ED is parallel with that diameter FG. That means you've got a transversal cutting two parallel lines, creating a whole bunch of alternate interior angles that are congruent. Now, and vertical angles are congruent, okay? And that vertical line, that axis of rotation, AC, that's going to cut a lot of things in half, okay? So you have a lot of triangles that have angle measures, corresponding angle measures that are the same. Now, that makes those triangles similar to each other, okay? Some of them are congruent. For example, these two triangles here, those would be congruent. These two triangles here are congruent. This triangle is similar to that triangle. This triangle is similar to that triangle. This triangle and this triangle are similar. This triangle and this triangle are similar, okay? Now, on your check for comprehension, I don't give you near that much information, okay? You're going to get a center point here. You're going to get this. And therefore, if you know that, you know this distance here. This is 0, 2. If this is the origin, this is 2 units. If I was to give you the x value of this point right here, you would know this distance here would be 4.8, or whatever x value I give you, okay? I don't think I give you the y value, okay? But can you find it? Can you find it? Of course you can. Now you can use some of your right triangle trig ratios. Is this a 90-degree angle here also? Parallel lines, 90? Yes, it is. All right? So you can use your trig ratios to find the lengths of all of the sides of those triangles. Now, why do you need the lengths? Because I'm going to ask you what's the volume of the right circular cone that's generated when you rotate triangle EDB and triangle FGB about that axis of rotation, AC. All right? To find the volume of a cone, 1/3 pi r squared times h. You need these, okay? And you're going to have to use your rules of similar triangles to find those h values, okay? And you're going to find them using your right triangle trig ratios. All right? Now that's kind of a cool problem. I like that one, okay? All right, so that's what you got for your CFC for Chapter 11. You got 2 problems that look an awful lot like that, okay? All right. You have today and 3 more academic days to get the rest of your assignments in, okay? There are a lot of you that are currently not passing, okay? When I went through my list on Friday, geometry, well, of all the students, man, I got a lot of people that are not passing. And the reason they're not passing is because they're doing the homework. Some of you are doing a phenomenal job on the homework, and I really appreciate that. I can see the work. I can follow your steps. You're doing a great job. And then there's some of you that are just flat copying the answers down. And you're not learning a thing. And I know that's true because you're not turning in your check for comprehensions. And those are worth a lot of points. So your homework, which is just answers, you're getting nothing for because I'm sending them back with zeros or very low scores because that's just not cool. And then you can't do the check for comprehensions. So, you know, that's the way it goes. If you're sitting at a 75 come Friday, the semester test, no harm, no foul, you cannot fail. You will pass, okay? If you're not sitting on at least a 75, you have to do something on the semester test to pass. All right, I'm going to get your semester test posted out here. I think I'm going to get it out there by Thursday. I think I can have it done and ready for you on Thursday. That gives you a lot of time to work on it, all right? I got to have it by Wednesday at noon is when I have to have those semester tests back. That way I know I have time to grade them. So keep turning stuff in. Keep turning stuff in. Don't let the zero stop you. Don't let the zero stop you. But please do the work, all right? And your semester test is just a flat, here's the problem, do the work, okay? Nothing hard, but you got to know how to do it. All right, well, that's all I got for you. Until tomorrow, keep pushing. A lot of you guys are doing an outstanding job. I thank you very much. That's most of you are doing a great job, but the few of you that aren't, please get on it. All right, that's all I got for you, man. May's out.